Welcome to Spaceverse, your portal to cosmic adventures. Get ready for a mind-blowing revelation that's shaking up our view of the universe. These findings are so out of left field that top scientists are starting to think that something huge is coming our way, something our current understanding of the cosmos just isn't prepared for. Andre Couteau, a postdoc researcher at the Lawrence Berkeley National Lab in California, recently shared, "We're here to let the universe tell us how it works, and maybe it's telling us it's more complicated than we thought." With every new discovery from the James Webb Space Telescope, we're uncovering a universe that's even more mysterious and complex than we could have imagined. Take this. Scientists just examined 30,000 ancient galaxies discovered by Webb and found something bizarre that doesn't fit the current theories on cosmic evolution. But hold on, it gets even weirder. Webb also studied another 20,000 early galaxies, and the results are just as mind-bending. This enormous study hints that what we thought was the universe expanding might actually be something entirely different, or even an illusion. Thanks to these jaw-dropping findings, many scientists are now seriously asking, are we on the brink of a groundbreaking discovery that could change everything we know about the universe? Could it be that the Big Bang isn't the true story behind the origin of everything? We're left with one question. Why are these numbers not matching up? They should be. It might mean there's something missing from our standard model, something beyond the dark energy and dark matter we keep talking about. Maybe, just maybe, there's a hidden piece of the puzzle waiting to be uncovered. So what exactly did the Webb telescope uncover about the early universe, and why are scientists suggesting this could spell the end of the Big Bang theory? A recent paper published in Nature Astronomy reveals that the James Webb Space Telescope has spotted a truly massive galaxy in the early universe, a cosmic giant whose light has traveled over 12 billion years to reach us. Scientists have dubbed it the Big Wheel. This colossal disk galaxy formed just 2 billion years after the Big Bang, when the universe was only 15% of its current age. Its discovery challenges everything we thought we knew about galaxy formation. The Webb telescope's detailed observations show that the Big Wheel is as large and fast-rotating as the biggest super-spiral galaxies we see today. In fact, it's 3 times larger than similar galaxies from that era and one of the most massive galaxies ever spotted in the early cosmos. According to our current cosmological model, galaxies from this time should appear smaller, less structured, and lack clear shapes. Yet the Big Wheel defies those expectations, standing out as a striking anomaly in the early universe. And it's not the only massive, well-formed galaxy Webb has found from this period. Several other similar galaxies have been identified. But what makes the Big Wheel stand out is that it is the largest galaxy of its kind discovered so far in the early universe. Hold on, there's more. Some of the latest discoveries from the Webb telescope have uncovered even more mind-boggling phenomena in the early universe. One of the most unsettling revelations involves dark energy. Scientists have discovered that dark energy, the mysterious force that drives the universe's expansion, might actually be changing in ways that challenge our current understanding of time and space. Some researchers now believe we may be on the brink of one of the most groundbreaking astronomical discoveries in a generation, one that could force us to rethink everything. This new finding contradicts current theories, some of which were shaped by none other than Albert Einstein. While more data is needed to fully confirm these results, even the most cautious and respected experts involved in the study, like Professor Ofer Lahav from University College London, are starting to feel the weight of the growing evidence. The discovery of dark energy back in 1998 was already a game-changer. Before that, we thought the universe's expansion would slow down due to gravity after the Big Bang. But a surprising observation from US and Australian scientists showed the universe's expansion was actually speeding up. With no explanation for what was driving this, they coined the term dark energy to describe the unknown force. Though we don't know exactly what dark energy is, astronomers have been tracking its effects by observing how galaxies move apart over time. Last year, researchers using the dark energy spectroscopy instrument picked up hints that dark energy might be changing. Initially, many thought it was just a data anomaly, but after more than a year of observations, scientists are now confident dark energy is behaving in ways we never expected. Professor Seshadri Nathather from the University of Portsmouth explained, We've conducted many more tests compared to the first year, and these results are giving us confidence that the findings aren't due to any unknown factors in the data we missed. Recent observations from the James Webb Space Telescope have also shown that dark energy in the early universe behaved differently than it does today. Lead author and Nobel laureate Adam Rees pointed out that Webb's data reveals something unusual. The universe's expansion rate, driven by dark energy, appears to change depending on how it's measured. For instance, when scientists analyze the cosmic microwave background, they get one value for the universe's expansion rate. But when they use predictions from our standard cosmological model, they come up with a completely different number. This discrepancy, known as Hubble tension, highlights a gap between the observed expansion rate and what the standard model predicts, suggesting that our understanding of the universe might be incomplete. Previously, scientists assumed dark energy drove the universe's expansion at a constant rate everywhere, which allowed them to determine the universe's age and how it evolved. But recent discoveries are challenging that assumption. Instead of staying constant, dark energy seems to behave in unexpected ways. Some regions of the universe may have experienced accelerated expansion at different times, which affects how we measure their apparent age. To address these mysteries, scientists have recently introduced a new cosmological model called timescape cosmology. In this model, they focus on the influence of large cosmic voids and structures on the passage of time. The key idea is that the expansion of the universe isn't caused by dark energy, but is rather an illusion shaped by time itself. According to this theory, time flows more slowly in areas with a higher concentration of matter. For example, an atomic clock placed within a galaxy might run a third slower than a clock in the middle of a vast, empty void. Over the immense timescale of the universe, this difference becomes even more striking. Although the universe is around 13.8 billion years old, time has passed faster in regions with less matter, like cosmic voids. This means that billions of extra years could have passed in the voids compared to denser regions. As a result, the universe doesn't have a single, unified age as we commonly think. Instead, its age might differ depending on where you are, being older in the voids and younger in more matter-rich areas. The most fascinating part is that, because more time has passed in the voids, these areas have undergone more cosmological expansion. In simpler terms, the universe has stretched more in the less dense voids. If you observe an object on the far side of a void, it would appear to be moving away from you much faster than an object on the near side of the void. This is because the space within the void has expanded more over time. Now picture this effect spreading across the entire universe. Over time, the voids grow larger and larger because they expand more rapidly. As a result, when we observe the universe, it gives the illusion that overall expansion is accelerating. However, in this model, there's no need to invoke dark energy. Instead, the faster expansion in the voids naturally explains the observed acceleration. In 2017, astronomers from the University of Canterbury in New Zealand tested the timescape cosmology model against actual observations and found it to be a slightly better fit than the lambda-CDM model for explaining cosmic expansion. Additionally, a recent observation by the Webb Telescope, studying 30,000 galaxies, revealed that most of them are rotating in the same direction. This is highly unusual because, according to the Big Bang theory, the universe should have formed in a chaotic way, with galaxies spinning in random directions. This unexpected uniformity suggests the universe may have begun with an initial spin, something current theories don't fully explain. What's even more intriguing is that some scientists are now entertaining the idea that the universe itself might have originated inside a rotating black hole. This concept isn't entirely new and is part of the black hole universe hypothesis, which proposes that our entire universe could actually be a massive black hole. These discoveries are truly mind-blowing, revealing even more mysteries about the universe and its astonishing nature. And that's a wrap for this video. If you found it interesting and informative, we'd love to hear your thoughts in the comments below. Thanks for watching, and we'll see you in the next deep dive into space.